We know that inverse of a function exists if function is 1 1 and on 2, that is function is bijective function. Trigonometrical functions are not 1 1 on 2 functions, so their inverse does not exist. To find the inverse of these trigonometrical functions, we have to restrict the domain and range. For example, if we take sin x, its domain is R as discussed earlier and range is -1 to 1. In this domain and range, the sin x is not 1 1 1 2. So we will have to restrict this domain with value, say -pi/2 to pi/2. This is called principal branch or principal value branch. So for domain -pi/2 to pi/2 and range -1 to 1, now it is 1 1 on 2 functions, and we have sin inverse x with domain as range of the sin x, it is -1 to 1, and range of the sin inverse x will be, it is -pi/2 to pi/2. Similarly, we can write the domain and range in the principal value branch. And these are cos inverse x, tan inverse x, cot inverse x, sec inverse x, cosec inverse x. And these values are, it is -1 to 1 and range is 0 to pi. In tan inverse x, this domain is R and range is -pi/2 to pi/2. Here we are using parenthesis, that means these corner values, that is -pi/2 and pi/2, are not included in this range. And the range domain of the cot inverse x is R, while the range is 0 to pi. Domain of sec inverse x is R minus -1 to 1, where its range will be 0 to pi, excluding pi/2. And for cosec inverse x, it is R minus -1 to 1 as domain, and range will be -pi/2 to pi/2, excluding the value 0. So these are the domains and the range of the inverse trigonometrical functions. We can draw the graph of the inverse trigonometrical functions by taking the mirror image of the trigonometrical functions about the y equal to x-axis. So for principal value branch, if we draw the graph of sin inverse x, on x-axis it is x, y-axis sin inverse x, domain is -1 to 1, and its principal value branch has the range from -pi/2 to pi/2. So graph will be as shown here. Similarly, we can draw the graph of the cos inverse x. In cos inverse x, the domain is again -1 to 1, and here the range is 0 to pi. So in between there is pi/2. So graph will be drawn here. At 0 it is 1, then it becomes 0 at pi/2, and at -1 the value, at pi it is the value -1. For tan inverse x, it has the range from -pi/2 to pi/2, while the domain is whole R. So graph is drawn here. And in similar way, we can draw the graph of cot inverse x, which has the range from 0 to pi. So in between there is pi/2, and its domain is also R. Therefore, the function will be on here. To draw the graph of the sec inverse x, the domain is R minus -1 to 1. So we mark the point -1 and 1. Sec inverse x will not have the value between -1 to 1, and its range is 0 to pi. So in between there is a pi/2 which is excluded. Therefore, to draw the graph of sec inverse x, the value will be from 0 to pi/2, and again here it is -1 at pi, and it is again reaching to pi by 2. So this is the graph of sec inverse x. To draw the graph of cosec inverse x, here domain is r minus minus 1 to 1, so we mark the point -1 and 1 on the x-axis. So value will not lie between -1 to 1, and its range is minus pi by 2 to pi by 2, minus pi by 2 to pi by 2, and its value excludes 0. Therefore, if we have to draw the graph and 0 is excluded, so graph will approach to 0 but will not meet here. So we'll have the graph like this, and here it is having the value -1 at value minus pi by 2 at -1. So graph will approach to 0 in this way. This is the graph of cosec inverse x.